Okay, so can you please introduce yourself and tell me about your recent project?
Yeah, sure. So I have around 3.5 years of experience as a Java backend developer, and during this time, I have primarily worked on Java, Spring Boot, microservices, REST API, SQL, JPA, Kafka, and various event-driven architecture. And my day-to-day responsibilities include like developing REST APIs, implementing business logic, fixing production-related issues, and optimizing existing services. And also, I participate in code reviews and collaborate with the QA and front-end teams as well. So in my current project, I am working on a personalization service where we customize the user experience based on the different user events. So since our like application follows an event-driven architecture, so services basically in this communicate using the asynchronous messaging, and that makes the system like more kind of scalable and loosely coupled. And apart from like feature development, I have also worked on the production support and performance optimization and debugging the complex issues in distributed applications. So yeah, so this is what is all about myself and my current project.
Okay, so can you please tell me what do you mean by event-driven architecture?
Yeah, so in event-driven architecture, instead of like one service directly calling another service every time, so services communicate by like publishing and consuming events. So let's say, for example, suppose a customer places an order, then the instead of order services calling inventory service, so notification service and analytics service one by one, the order services simply publishes an order created event. Okay, and now like inventory service, notification service, and like email service, and the other services can independently consume that event and perform their own work. So that is what is the event driven service, and this actually makes the service like kind of, we can say, loosely coupled, and it also improves the scalability because like new consumers can be added without modifying the producer service, right? So yeah, so in projects like Kafka is one of the most common messaging system used for the implementing this architecture. So this is what is all about this event driven architecture.
Okay, so let's say you have a shared cache that is being accessed by multiple threads. Okay, so you used a hash map, but the data is getting corrupted. So, what could be the issue? Can you tell me?
Yeah, so the first thing that comes to my mind in this case is like that hash map is not thread safe. Okay, so if multiple threads try to read and update the same hash map simultaneously, then there can be data inconsistency because like hash map does not perform any synchronization internally. Okay, so in older Java versions, like concurrent modification could even lead to like infinite loops during the rehashing. So in such scenarios, I would simply replace hash map with concurrent hash map because it is specifically designed for the concurrent access. Okay, so if thread safety is the primary concern and performance is not critical, then hash table is another option. Okay, but as we see, like nowadays concurrent hash map is generally preferred because it offers like much better performance, and yeah, so that's what we can think of. Yeah.
Okay, so why is concurrent hash map is faster than hash table?
Yeah, so the main reason I would say is the locking mechanism. So hash table synchronizes every method. So that means that like entire map gets locked even if the two threads are accessing different keys. Okay, and concurrent hash map works much more efficiently. Okay, so basically it allows multiple threads to read simultaneously, and during write operations it does not lock the entire map. Okay, so instead like it uses like finer grained synchronization internally, we can say, so that actually significantly improves the performance under the heavy concurrent access. So that is why in the modern Java applications concurrent hash map is usually more preferred over hash table, and that is why like concurrent hash map is kind of faster than hash table. So yeah.
Okay, so in your project, where have you actually used concurrent hash map?
Yeah, so one common use case is caching. So suppose we frequently read configurations data or look up information that is shared across the multiple threads. Then instead of querying the database every time, we cache the data inside a concurrence hash map. Okay. So since many requests may access the cache simultaneously, then concurrent hash map ensures thread safety while still providing the good performance. So yeah.
Okay, fine. So suppose you have overridden the equals method but forgot to override the hash code. Okay. So what problems do you think can occur because of this?
Yeah, so whenever we use a custom object as a key in hash map or hash set, then like it's very much important to override both equals and hash code together. So because they have, I mean, equals hash code contract. So hash map first calculates the hash code to identify the bucket where the object should be stored, and if two objects are logically equal according to equals method, but they generate the different hash codes, then they may get the stored in the different buckets. Okay, so later on when we try to retrieve the object, then hash map may not find like it very even though an equal objects exist also. Okay, so this actually leads to the incorrect or inconsistent behavior such as like duplicate entries or kind of failed lookups and all. So whenever we override equals method, then we should also override the hash code to maintain the contract between them. So that is why both are required to override. Yeah.
So can two different objects have the same hash code?
Yes, it can have. So two completely different objects can generate the same hash code. So like actually this situation is called hash collision. So hash map handles collision internally by storing the multiple entries within the same bucket. So when it goes to retrieve the data, then hash map first checks the hash code and then uses the equals method to identify the correct object, and that is how it gets the data. Yeah.
Okay, so do you know the singleton design pattern?
Yeah, I know that. Yeah.
Okay, so can you tell me what is the best way to implement singleton in Java?
Yeah, so the best way is actually using an enum. So that is the safest and simplest approach. So Java ensures that enum instance are like created only once in by JVM. Okay, so that is the best way actually.
Okay, so can you still break the singleton?
Yeah, we can break it. So there are some ways like if we are using the traditional singleton implementation, then it can still be broken using reflection. So that is the one of the way. So reflection can access the private constructors and create the another instance. Okay. Similarly, like serialization can also create a new object during the deserialization. So if we don't handle it properly, then to I mean this can also break that. To prevent these issues, like enum based singleton is recommended because the JVM itself guarantees that the only one instance exists. So yeah, so if it is not enum way, then these are the challenges we may face. Yeah.
Okay, so why do we use builder design pattern? Can you tell me?
Yeah, so builder pattern is like mainly useful when a class contains like many optional fields. So suppose we have an employee object with 10 different attributes. Then if we use constructor, then we will either end up like creating many overloaded constructors or like passing the lots of null values. Okay, so that makes the code like difficult to read and maintain. But builder design pattern solves this problem by allowing us to set only the like required fields in a clean and readable way. So that is why we use this design pattern, and it also makes the code like much easier to understand. So yeah.
Okay, so since we are discussing collections, can you tell me the difference between hash map and linked hash map?
Yeah, sure. So the biggest difference between these two are like the hash map does not maintain any order, whereas linked hash map maintains the insertion order of elements. Okay, so that's the main difference. And internally, hash map stores the entire entries using the buckets. So based on the hash codes. Okay, a linked hash map also uses hash map internally, but in addition to that, it maintains a doubly linked list between the all entries. Okay, so that's how it remembers the order in which the elements were inserted, and because of this like extra linked list, link hash map uses a slightly more memory than hash map. So yeah, so that's the main difference between these two.
Okay, fine. So can linked hash map also maintain the access order instead of insertion order?
Access order, yeah, it can do that. So by default, linked hash map maintains the insertion order. But while creating it, we can enable access order mode by passing a boolean flag in the constructor. So in that case, whenever an entry is accessed, then it gets moved to the end of the linked list. Okay, so that feature commonly used while like implementing some LRU, like least recently used cache, where the last recently accessed entry is removed first. So yeah.
Okay, so let's move to multi-threading. So can you tell me what is synchronization?
So synchronization is used when multiple threads are trying to access the same shared resource. Okay. So without synchronization, two or more threads may update the same data simultaneously. So that can lead to inconsistent result to or race condition. Okay, and synchronization ensures that only one thread can execute the critical section at a time while other threads wait until the lock is released. So this guarantees the data consistency actually. So that's what is the synchronization.
Okay, so do you think if there is any disadvantages of synchronization?
Yeah, we can say like although synchronization provides like thread safety, excessive synchronization can also reduce the application performance. So that's the main thing. So since only one thread can execute the synchronization block at a time, so other threads remain blocked. Okay. So if synchronization is used unnecessarily, then it increases the waiting time and reduces the throughput. So that's the main issue. Okay. So that's why we should like synchronize only the critical section instead of entire like method wherever possible.
Okay, fine. So what is concurrent modification exception?
Yeah, concurrent modification exception usually occurs when we modify a collection while iterating over it. So, for example, if we are using a for each loop, okay, so over an array list and remove an element directly from the list during the iteration, then Java throws the concurrent modification exception. So, yeah, so that's what is the concurrent modification exception.
Okay, so can you explain with example about the single responsibility principle?
Yeah, so like suppose we have an order service, okay. So if this service validates the request and saves the data into database and then sets the email, generates invoices and writes logs, then it has multiple responsibilities, right? So instead of that, we can spread these responsibilities. So that's the meaning of that. So like validation would go into maybe validator class, then database operations would be handled by the repository, then email functionality would be moved to the notification service, okay, and also like invoice generation can go to some other component, okay. So like that makes the every class like easier to maintain and test. So that's what is the meaning of the single responsibility principle.
Okay, fine. So can you tell me why do we prefer constructor injection instead of field injection?
So we prefer the constructor injection because it makes the dependencies mandatory. Okay. So if a required dependency is missing and the application fails immediately during the startup instead of causing a null pointer exception later. So that's what that's why we prefer the constructor injection. And it also makes the unit testing kind of much easier because dependencies can be passed directly while creating the object. And another advantage we can say is that like it injected the field can be declared as a final. Okay, so that makes the class immutable after construction. Okay, so that's why like constructor injection is generally considered as a best like practice in the Spring Boot. So yeah.
Okay, so can you tell me what is volatile keyword?
Yeah, so the volatile keyword is used when a variable is shared between multiple threads and we want like every thread to always read the latest updated value. Okay, so normally each thread may keep its own cache copy of the variable. Because of that, one thread may update the value, but another thread might still continue reading the old value. Okay, when we declare like a variable as volatile, then Java ensures that like any update made by one thread becomes immediately visible to all other threads. Okay, that's what is the volatile keyword.
Okay, so can volatile replace synchronized?
No, both are the of different purpose. So like volatile only guarantees the visibility of changes across the threads. Okay, and synchronization provides both visibility and mutual exclusion. So that's the main difference. So for example, like let's say if multiple threads are incrementing a counter, okay, and then using the volatile alone, it is not enough because like increment is actually multiple operations. Okay, so like read, increment, and then write. So in that case, synchronized block locks or atomic integers would be used. So that's what.
Okay, so can you tell me what is wait, notify, and notify all?
Yeah, so these methods are used for communication between threads. So wait method used like that causes the concurrent current thread to release the lock and move into the waiting state. So that's what is the wait. Notify actually method wakes up one waiting thread. So that's what is the notify. And notify all method wakes up the all waiting threads associated with that object. So that's the main difference. So these methods must always be called inside the synchronized block because they depend on the object's monitor. So yeah, so that's what is the main difference between these three.
Okay, fine. So can you tell me what is optimistic locking?
Yeah, optimistic locking assumes that like conflicts between transactions are rare. Okay, so instead of locking the record immediately, so it allows multiple users to read and update the same data. So before saving, like it checks whether another transaction has already modified the record. And in JPA, this is like commonly implemented using the add date of version annotation. So if the version has changed, then JPA throws an optimistic lock exception. Okay, and the application can retry or notify the user. So yeah, so this approach basically provides the better performance than the write conflict are like kind of uncommon.
Okay, so now can you tell me what happens internally when you start a Spring Boot application?
Yeah, so whenever we run a Spring Boot application, then the execution starts from class containing the main method. Okay, and inside the main method, we usually call Spring Boot application.run method. Okay, and once this method is executed, then Spring Boot starts creating the application context, which is basically the IOC container responsible for managing all Spring beans. Okay, and then it performs the component scanning to identify classes annotated with the annotations like we have add component, add service, add repository, add controller. So all these will be scanned. Okay, and after that Spring creates the required beans and then perform the dependency injection and applies the auto configuration, initializes the embedded Tomcat server if it is web application. Okay, and finally after that the application starts accepting the request. So yeah, so in short, like Spring Boot handles all initialization steps automatically before the application becomes ready. So yeah.
Okay, so can you tell me what is application context?
Yeah, so application context is the like central container in Spring. So its main responsibility is to create, configure, and manage all Spring beans. So whenever a bean depends on another bean, the application context automatically injects the dependency. Okay, so apart from the dependency injection, it also provides the features like event publishing, a bean lifecycle management, and then internationalization, then profile support. So all these are also functionalities are present in this. So yeah, so that's what is the basically the application context.
Okay, and how it is different from Bean Factory?
Yeah, so Bean Factory, we can say it is like kind of basic IOC container. Okay, so that is the basic IOC container provided by the Spring. So like for example, let's say application context supports like event publishing, annotation based configuration. Okay, and then Spring AOP. So all these are additional features are there, but those things are not there in the Spring Bean Factory. Okay, so mostly we use application context only. So in the major projects.
Okay, and what is auto configuration?
Yeah, auto configuration is one of the biggest advantage we can say of Spring Boot. So instead of manually configuring every bean, Spring Boot automatically configures many components based on the dependencies available in the project. So for example, let's say if I add a Spring Data JPA dependency and provide the database properties in the application.properties file. Okay, so Spring Boot in that case automatically creates the data source and entry manager and transaction manager. So similarly, suppose if I add the Spring Web dependency, then it automatically configures the embedded Tomcat server and dispatcher servlet. So we don't have to explicitly go and do all these setups. Okay. So yeah, so that's what is the basically the use of the auto configuration.
Okay, then suppose if I don't want any particular auto configuration, so can I disable it? Is there any way?
Yeah, we can do that. So there are multiple ways actually. So one common approach is like using the exclude. Okay. So that attribute you can use in the add date of Spring Boot application annotation. So we can also disable the and like certain configurations through the properties in the uh, 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 Spring Boot configuration itself, like properties. So that itself provides. Yeah. So if an auto configuration like is not needed, then we can easily exclude it. So yeah.
Okay, so can you explain what add rate of Spring Boot application actually does?
Yeah, so actually this add date of Spring Boot application is the combination of three other annotations. Okay, so the first one is add date of configuration. So that tells the Spring that the like this class contains bean definitions. Okay, so that is the meaning of add date of configuration. Then the second one is add date of enable auto configuration. So that enables a Spring Boot auto configuration feature. So that's the use of that. And then the third one is add date of component scan. So that tells the Spring like where to scan for the components like we have controller, service, repository. So where to scan those. So that is the main difference between these three. So instead of writing all these three annotations separately, so Spring Boot provides this one common add date of Spring Boot annotation to which we can add, and that will also behave the same way. So yeah.
Okay, and what are Spring Boot starters?
Yeah, so Spring Boot starters are we can say like pre-packaged dependency bundles. Okay, so instead of adding like multiple individual libraries manually, we simply add one starter dependency. So for example, Spring Boot starter web, so that automatically brings in the Spring MVC, then Jackson validation, then embedded Tomcat and other required dependencies. And similarly, let's say we have Spring Boot starter data JPA, so that includes the Hibernate Spring data JPA, transaction support and other required libraries. So that makes the dependency management much easier, and that is the use of these starters.
Okay, and what are Spring profiles?
Yeah, Spring Profiles allows us to maintain the different configurations for different environments. So for example, let's say we have multiple environments, let's say local, dev, QA, UAT, production and all. So each environment may use a different database URLs and API endpoints or logging levels. Okay. So instead of changing the configuration manually every time, we create separate property files for each profile. So okay, so then we activate the required profiles while starting the application. So that's the use of the profiles.
Okay, and can we activate multiple profiles at the same time?
Yeah, we can do that. So Spring allows multiple profiles to be activated simultaneously. So like this is useful when we want to combine the like common configurations with environment specific configuration. So in that case, we can use it. For example, we suppose if we want to activate both, let's say something like common is there and one is the dev profile. So we want common and dev to have it together, then we can use it. So Spring merges the configuration from both profiles, and if the same property exists in multiple places, then the higher priority configuration takes in precedence. So that's the main thing we have to remember in this while using this like more than one profiles.
Okay, so suppose there are two implementations of the same interface. So how does Spring knows like which one to inject?
Yeah, so if there are multiple implementations, then Spring throws an exception because like it does not know like which bin to inject. So actually to resolve this, we have some like solutions. So we can use, for example, add rate of qualifier annotation and specify the exact bin name. Okay, and another option is like we can use add data primary annotation. Okay, so if one implementation is marked as add data primary, then Spring injects that bin by default wherever there is ambiguity. So that is the main difference between these two, and this is what we can use it.
Okay, so suppose your Spring Boot application all of a sudden takes like kind of 2 minutes to start instead of quickly. So how would you investigate that?
Yeah, so in this case, the first thing we can check is the application startup logs to see where the most of the time being spent. Okay, and then we can verify like whether any external system like databases, Kafka brokers, or third-party APIs are delaying initialization. Okay, and then I would also look for unnecessary bean creation and slow initialization methods or like expensive startup logic. So these things we can check, and if the application has too many auto configurations, then I would check whether like some of them can be excluded. Okay, so using a Spring Boot actuator and a startup matrix can also help like identify slow initialization. Okay, and finally we can I would profile the application if needed and optimize the startup based on the findings instead of making the assumptions. So yeah, so these are the steps we have to follow.
Okay, so can you tell me why do companies prefer microservices over monolithic applications?
Yeah, so there are many reasons for this. So, like the biggest advantage is like independent deployment. So we can deploy the each services like independently. And suppose there is a small bug in one of the service, then in monolithic application we usually have to deploy the entire application again. But in microservices we will only have to deploy that specific service. So that is the main advantage. Another advantage we can say is scalability. So if the payment service receives like heavy traffic and other services have like kind of usual traffic, then we can scale only that specific service instead of like scaling the entire application. So that is also one big advantage, and this ultimately saves lots of money for the like client. And if like it also allows the different teams to work independently on different services, so that is also one of the main advantage. So that actually increases the development speed also. So these are the like few major advantages, and also another advantage we can say like each service uses its own technology it can use. So some of them can be on .NET, some of them can be on Python, some of them can be on Java. So it all of their choice, and also databases also can be the like separate. So it all depends on the that specific microservices. So that these are the like I would say like major advantages are there, and why companies prefer microservices.
Okay, so why can't the front end directly call every microservices? So we have 10 microservices, right? And suppose in a UI, all those 10 different microservices are being used. So we can call it separately, no? Why we have to go through any specific way or how it actually happens?
Yeah, so actually technically we can do that. So front end can always call any specific microservices also, but it is not a good design. Okay, so the front end would need to know the address of every service in this case if it has to call the any specific microservices. So if a service changes the its URL or gets split into multiple services, then the front end also needs to modification, and we have to redeploy the front end also, back end also, and we have to make changes also. Okay, so it also creates the security concerns because like every service becomes directly exposed. So this is also the security concern. So using an API gateway, actually we should do these calls. So that hides these implementation details and provides a centralized place for authentication and routing and monitoring. Okay, so we can make the call to API gateway, and API gateway further calls those services whichever is required. So that is the actually good design for that.
So have you worked on service discovery?
Yeah, I have worked on that. So in microservices, services instance may be created or removed dynamically. So instead of hard coding the service URLs, so services discovery allow like services to register themselves with a registry like Eureka, or we have like a console. So wherever like one service wants to call another, then it asks the registry for the current location instead of using the fixed IP address. Okay, so this location would be keep on changing dynamically. Okay, so that's actually makes the system like much more flexible and scalable. So that's what is the service discovery.
Okay, and what is load balancing?
Yeah, load balancing means like distributing incoming request across the multiple instances of the same service. Okay, so for example, suppose we have three instances of the payment service. Okay, so instead of sending every request to one instance, the load balancer distributes them among all three. So this improves the performance and availability and fault tolerance. Okay, so if one instance goes down, then traffic is automatically redirected to the remaining healthy instances. So that is what is a load balancing.
Okay, so what is circuit breaker and can you tell me the different states of it?
Yeah, so circuit breaker is a design pattern that is used to prevent the cascading failures. So suppose like let's say order service is calling payment service. So if the payment service goes down, let's say, then we don't want the order service to keep waiting like for timeouts on every request. Okay, so the circuit breaker detects the repeated failures and temporarily stops calling the failing service, and instead of that it returns the fallback response. So we can give anything as per the business logic. Okay, and coming to its states, like it has various states, like it has like closed, then it has open, and then it also has like half open. So these are the various states of it.
Okay, and what is eventual consistency?
Yeah, so in distributed system, data may not become consistent immediately. Okay, so instead, like all services gradually become consistent after processing the required events. So, for example, after placing an order, so inventory service might update immediately while analytics service processes event a few seconds later. Okay, so eventually every service reaches the same consistent state. So this approach is like kind of very much, we can say, common in event driven microservice architecture. So that's what is the eventual consistency.
Okay, so coming to SQL, can you tell me the difference between delete, truncate, and drop?
Yeah, so delete actually that removes the row one by one, and we can use a where clause to delete the specific record. Okay, and truncate removes all rows from the table at once. So like it is, we can say, much faster because like it delocates the data pages instead of deleting the rows individually. Okay, and drop is like completely removing the table itself. So that is the drop. So that is the main difference between these three.
Okay, so how would you identify a slow SQL query in production?
Yeah, so for that, first of all, we can identify like which query is taking most of the time using the database monitoring tool or any kind of application logs. Okay, so after that, we can check the execution plan to see like whether indexes are being used or not. And if we notice like a full table scan on a large table, then so if I notice a uh, full table scan or large table, then I would investigate like whether an index is missing or something else is there. Okay, and after that I we can also check for any kind of unnecessary joins or subqueries or like repeated database calls. So sometimes this issue is not SQL itself but the amount of data being fetched. So it all depends, like we have to go step by step for this.
Okay, so what is save and what is save and flush?
Yeah, so save method stores the entity in the persistent constant context. So the actual SQL may be executed later when the transaction is committed or when Hibernate decides to flush. Okay. On the other hand, save and flush immediately synchronizes the persistence context with the database by executing the SQL statement. Okay. So in most business scenarios, save method is sufficient, but save and flush is mainly useful when we like need the changes to be available in the database immediately within the same transaction. So then we can go for the save and flush.